Hey everybody, welcome to your first video lecture. I'm going to try to keep this short. We're only going to talk about 5 things. Those 5 things this time are map types. You should, as you watch this video lecture, take some notes, write some stuff down so that you understand this stuff. That's why I'm giving you a lecture, so that you can understand it. If there is vocabulary in here, it is in red, meaning that you need to know what that word means. In this case, it refers to the particular type of map. So we're going to talk today about 5 different types of maps, each of which you need to know. Those types of maps are, they're called thematic maps because they all follow a particular theme. So those 5 types of maps are isoline map, choropleth map, cartogram maps, proportional symbol maps, and dot maps. For each of those, you're going to need to know what it does, what each of them does, and why someone would use them, so what their uses are. Let's get right into it. Let's start with an isoline map. Here's an example. An isoline map, by definition, connects points of equal value. So what you got to think here is that the cartographer, the person who is making the map, is trying to represent a particular type of data. And in an isoline map, that data it isolates itself. Different values isolate themselves on the map. Okay, and you'll see this as a contrast to choropleth maps, the next thing that wants to come up, or that we're going to talk about. So in this particular example, this is today's air quality index, which is, say, Friday, September 18th. And you see that the air quality data itself creates the different colors on the map. Okay, so that's important to note, that the data creates its own region. So you see that there are the green regions, which is one variance of data. There's the yellow regions that are the different variants of data, and so on. Okay, as another example, topographic maps are isoline maps. If you've gone hiking or backpacking, you've probably used a topographic map. What they do is they show elevation. So in this case, each of the lines that you can see there represents a separation between different points of elevation. Maybe you can make it out, but right here it says 3,200. That would be feet above sea level, 3,600 feet above sea level. So each line in between represents a different variance in the data, again creating its own blob on the map. So topographic maps, you should probably know that term as well. Okay, as a contrast to isoline maps, you get choropleth maps. The difference between isoline and choropleth is that choropleth maps allow the data to be averaged across a man-made region, a human-made region. In the case of both the maps on the top there, you see that they're averaged over counties. Now, the difference between this and an isoline is that the isoline map lets that data be wherever it's going to be on the map and create its own regions. Choropleth maps, we use our own regions and we average the data across that particular region. Okay, so let me give you an example as a contrast to the air quality map. Here is your air quality today, again, by county. So you see that this is pretty different from the air quality index when we let the air quality data represent itself. Now we're saying in each of these counties averaged across the county, this is the air quality data. So yeah, this becomes much more geographic. The isoline tend to be the blob maps. Okay, let me know if you have any questions about those. Those are the 2 most confusing. All right, let's move on. We have proportional symbol maps, which are exactly what they sound like. There are symbols on the map that are in proportion to the data that they're representing. For instance, the map of Europe on the right of your screen there, that is the number of internet users per country in Europe in 2004. So you see that the circles are different sizes for the different numbers of internet users. When you look at the map on the left, you see, at least when it comes to the pie charts, the proportional symbols, in this case of debt in African countries versus their GDP. And the funny thing is the GDP here, the blue parts are represented as choropleth over the man-made regions of the countries. So we've got two different types of thematic maps mixing there. It's the symbols that are the example of proportional symbol map. Here's another example of proportional symbol map, going with the theme that I've been talking about, which is the air quality and the fires and so on. Here is a proportional symbol map of the areas of concern for particulate matter and ozone. In other words, essentially air quality. So the bigger, in the case of this map, the bigger the symbol on the map, the more parts per million there are of particles in the air. The smaller the map, the less. Okay. Now again, this one is combined, like the one of Africa before. You see underneath it the purple gradations. That's an isoline map of the likely contribution to ozone layer levels in that particular area. So again, a combined map, kind of cool, but isoline in this case, not choropleth. Okay. These are the coolest. I love cartogram maps. What a cartogram map does is it adjusts different regions for the amount of it adjusts the actual size of the region on the map for the amount of data that's in that region. In this case, we're talking human population. So you see here that China is fantastically large, and so is India. Those two are massive because they're the two most populous countries in the world. And then you go over to, I don't know, something tiny over here like Kosovo, which you can't even see on the map because the population is so small. Brazil is huge. United States is huge. Mexico is huge. Okay, so on and so forth. So it changes the size. This next map I think is really cool. I got to introduce this one before I flip to it because it's a GIF, so it'll start playing right away. The next map is a cartogram of the spread of the coronavirus across the world. It really gives you an idea of how a cartogram works because it's adjusting the size of the countries as the coronavirus cases in those particular countries either grow or shrink. So let's go to that one. Come on. Okay, fine. Apparently it's not going to work. Let me see if I can get it this way. Nope, not gonna work. Okay, whatever. It's a super cool map. It started in January, where over here China is freaking massive, and then it goes all the way through July, where over here on our side of the world, it's much larger. China's India actually being huge right now, or in July anyway. So again, cartogram maps adjust the size of a country based on the amount of data that's in it. Okay, last style of map, dot map. With a dot map, like it says, each dot represents a fixed frequency of something. And this is different from the proportional symbol. The proportional symbol, remember, the symbol is a different size depending on the data that's represented by it. In a dot map, all of the dots, or symbols in this case, are the same size. Each one represents a particular amount, the same amount. In this case, we're looking at casualties in World War II, where every symbol, and this may blow your mind, where every symbol represents 100,000 casualties. And that doesn't necessarily mean deaths, but injuries and deaths. In this case, each symbol is a national symbol where those 100,000 people came from. In the case of Russia, you've got so many hundreds of thousands of Russians and so many hundreds of thousands of Nazis or Nazi Germans, and so many hundreds of thousands of Jewish people, and then so many hundreds of thousands of civilians in this case. So, dot map. Another representation of dot map, and sticking with the theme, we got your fires and your air quality index. Now this one, each dot represents just where we're taking the information from. Where you see the fire symbols, that each of those symbols or dots is one fire, and then the different colors of the circles represent the air quality. So, all right, that's it for map types. Now you'll be able to answer your questions in your week 3 tasks. Email me if you have any questions, and we'll talk about it in the meets as well. See ya.